Okay, so boxes of a certain cereal say they hold 20 ounces. To make sure they do, the manufacturer fills the box to a mean weight of 20.3. So let me make sure you understand this. So the way manufacturing works is nothing's perfect. So when they fill boxes of cereal, for example, if they write on the box 20 ounces, they have to program in the factory the machines that fill the boxes to do a little bit more, like 20.3 is just a little bit higher than 20. Why? Because 20 is what they promise, 20.3 is what they'll aim at, because of the fact that not everything's perfect. And so basically, machines are affected by temperature. If it's hotter in the factory, metals expand. If there's more humidity, they haven't been oiled, they get older, all these things. And they try to control all that in factories. They try to control the temperature and the humidity, and they keep the machines repaired. They do the best they can. But there's variation in everything. And so nothing comes out perfect. And the truth is, manufacturing processes, assembly plants and such, they know that things happen in a normally distributed fashion. They know all about this normal curve. And that's how things happen in real life. It's what normally happens. So, what do they do about that? Well, what they do is they don't want to be unfaithful to their promise. So if they promise 20 ounces, they program the machines to put a little more than 20 ounces, knowing there'll be a little variation, sometimes above, sometimes below. And then they calculate using what we're doing right now, statistics. They figure out what percentage of the time they're going to be fulfilling their promise. Nothing's perfect. Everything goes wrong sometimes, but they don't want it going wrong a lot. That would be a problem. So here's what they're doing. They're saying, okay, the mean weight, the average weight is 20.3. So we'll put that right in the middle. That's the average. And then standard deviation is 0.15. So that's how far from line to line it goes up. 0.15. So what would that be then? 20, if you add 0.15, 0.45. And then for the next line, up another 0.15. This would then be, what is it, 20.6. And then add another 0.15. This will be 20.75. And then the other direction, it's like a number line, right? 20.3 is in the middle instead of 0 in the middle. The average, what the machine does on average is in the middle, 20.3. And then the other direction, I'm going to subtract 0.15 because it's doing below average. So what's that going to be? 20.15. And then do it again, minus 0.15. This is going to be 20.0 exactly, and then minus 0.15 one more time. This will be 19.85 for this line. Okay, so that's what the machine's going to do according to those percentages. Let's answer their questions. If the weights have a normal curve, that's how we knew we were supposed to do this. By the way, this is not part of the problem. I grabbed this normal curve out of your book, pasted it in here. So make sure on the exam you have a copy of this normal curve because you will need it for several problems on the next exam. If the weights have a normal curve right there, whoops, I kind of scribbled that out. So the weights have a normal curve, then what? What percentage of the boxes actually contain 20 ounces or more? So here's the actual 20-ounce line right there. How many of the boxes are in this zone, right? 20 or more. Well, we could add up this percentage, this percentage, this percentage, this percentage, this percentage, this percentage. We could do that, or what would be easier would be to add up this percentage and subtract from 100, right? So these two, 0.15% and 2.35% is 2.50%. That's what's below 20 ounces. That's what percentage of the time the machine will fill below 20 ounces. So what percentage of the time will it fill 20 or more? You got to take 100% minus 2.50%, 97.5%. of the time. So that's the answer. 97.5% of the time, there will actually be 20 ounces or more in the box. So there.